For the last two problems, yet again, another technique for a different situation. Today we're just looking at these first two. In these situations, we do have a sine and a cosine, but they're both to exponents. In the past, we've had it where one was raised to an exponent, the other one wasn't. We could do that with basic U substitution. But here, if they're both raised to a power other than 1, then we're going to have to do a little bit differently. Basically, it depends on which one is raised to an odd integer. If one of them is raised to an odd integer, or both, we can do it either of these ways. Basically, kind of like our first technique, taking one out of that odd integer. And if they're both even, that's using half angle formulas, which we'll do later. But basically, if one of them's odd, we're taking one out of there. So if we look at number 5, cosine is cubed. So that's an odd one. We're going to take a cosine out of that. We're going to make a cosine squared times sine to the 4th. And we're going to put that cosine, the extra one that makes it cubed, at the end. Then what we can do here is we can write all of this in terms of sine, right? By taking this cosine squared and using the Pythagorean identity. 1 minus sine squared times sine to the 4th times cosine of x dx. Now, this first part is going to be in terms of sine. We want to distribute that to both of those terms. We get sine to the 4th minus sine to the 6th times cosine of x dx. Now everything in the parentheses is in terms of sine, and we've got cosine of x here. So if this is all in terms of sine, we're going to set u equal to sine of x, which means du would be cosine of x dx, which we have right there. So basically we have the antiderivative of u to the 4th minus u to the 6th du, which is a basic integral. We get 1/5 u to the 5th minus 1/7 u to the 7th plus c. And our last step, all we have to do is put sine of x in there. So we have 1/5 sine to the 5th of x minus 1/7 sine to the 7th of x plus c.